first, then you increase. Down milling, you take the undeformed chip thickness is big, okay, and you have to have rigid machine too. If not, we can't do it at all. Okay.
Yeah, sir. Back in college, when we had to do our machine shop and we were doing all our milling, the teacher would get pissed when he would see people doing down milling.
Yes, this is because of the machine tool.
Yeah, because he was worried that the tool was going to break because of the amount of thickness of the chip that they're taking off.
Yes, but now after I explained to you, right? Probably in the college when you're working on this, is low B and N number. It's fine to do what? Up milling.
It was like aluminum.
There you go. But if you have high hardness, you can't do it anymore. Okay, you're gonna break your tool. Okay, so Ryan asks, so sir, the spindle direction just change, two parts will be the same. Right. You cannot just change your spindle rotation because tools, the tool over here can either cut in clockwise direction or usually it's clockwise direction, the tool can cut. If anti-clockwise, it's just rubbing. So you cannot just change the spindle rotation. You cannot change this.
Correct me if I'm wrong, but when you're in NC control and you're doing down milling, when you're doing climb milling, the person fluctuates with their feed speed. So if they were to feed too fast while they were down milling, that could cause an issue as well.
Yes, yes. So it's what we call the approach on the initial engagement. So there are software that you can control the initial, we call the initial engagement. That's true. Okay. So I answered Ryan's question. Risk is the difference between lathe and milling is that in a lathe the material is spinning, but with milling the cutter tools. Yes, Reese, you are right. Another thing is in turning, you generate round workpiece. In milling, it's rectangular. Okay, you cannot do anything cylindrical. Okay, I mean normal milling. Okay, we're not talking about 5 axis or whatsoever. So now I'm going to draw up milling in conventional or in milling operation. So how does it look like? Okay. So I did not get rid of this because I want you to compare. So now we do up milling. So as I mentioned to you all before, the tool spins in the same direction. Okay, so this is our cutter. Okay, the direction did not change. Okay, same direction of rotation. Now, where the workpiece is different. Yeah, you can see the difference, right? So this is now our workpiece, material, linear motion. Okay, and then if I were to sketch our next path, the next path will look like this. And then the next path, this is exaggerated too much. Okay, so this is revolution number 1, revolution number 2, and revolution number 3. Okay, and this is the, so you can see when we start at T mean, And when we finish off with Tmax, right? And again, in this region is our engagement region, right? So you can see now the chip ended up in front now. Okay, this is where the chip is. So you can see, like, so what you see over here. So the workpiece is moving down. The tool is opposing it now. Okay, so tool and workpiece are in the tool and workpiece engagement region, right? The feet or the workpiece material direction is opposite to the tool direction. Right, one arrow is going upwards, the other one, the arrow is going downwards. So the chip will fall ahead of the tool. Okay, and this is sometimes bad news, right? Is why is bad news is the tool can pick up the chip and engage again and hit with the workpiece. Whereas for this case, the chip is left behind, the tool is going that direction, right? Okay. So now, in order to cut in up or down direction, or in order to cut up or down milling, okay, we have to adjust, or we have to plan we have to plan the cutter path. Okay, and I'm going to explain to you what do you mean that we have to plan the cutter path now. Okay, so I want you to see what we are dealing with now in terms of the difference between up milling and down milling. Okay. So if we have, this is our workpiece material. Right. And this is our tool. And our tool rotation is going this way. Okay. So so this is what I meant by cutter path. Okay. So we will get to move our tool in this direction. Okay. Then we come here, right? And so when it come here, it goes me, okay, right? It goes and comes. So what we see down here, right? This is doing what? Okay, so this is going this way. This is doing down milling. Okay, so this is what we mean by cutter path. Basically, cutting to position. Okay, so it goes out this way. So one of the strategy that we use is we call it zigzag. Okay, then we will offset right? We will offset, then we go me, right? The problem with this is what, right? So the problem when you do this, right? So the first one is down milling. I mean, yeah, this is so now if our 2 is here, right? And then it will now this is the material that is not cut yet. Okay, so this side is the material that's not cut yet. Okay. Now the 2 will be if I were to draw the engagement of the 2, right? So this is our 2 now, right? The 2 will do this, right? And then it will cut like this. Me. So now this is now up milling. And then when we come down, we step over, and then we go down me. This way will be what? Down milling. Okay. So this strategy is combined up and down milling. Okay. The me thing. Okay. So this is okay for low B and N. Okay, for low B and N. And then if we were to have high B and N, right, we have to replan our cutter path. Okay, and I hope you all join me in the me. Okay. Yeah, you need some bloody humor teaching this course. So if now this is my tool or my workpiece, right? And this is our tool. And to do down milling. Hey, you all cannot see what I'm writing down here. Seriously, you can. So just to do down milling only. Okay. Okay. What you have to do is this. Okay. You come over here, right? Right. You do me. Come on, you guys are not joining me. Unmute your microphone. You need to relieve some of your stress, man. You will move out of the workpiece, right? Then you will go back over here. And then you will come over here and you will go me, right? Right. Then you will step over again. Me. Yes, there you go. So this cutter path is what we call down milling only. If you were to go opposite, it's just up milling. If you go zigzag, okay, then yeah, you will combine up and down milling. Okay. Now there's another operation that combines up and down milling, not by choice, but by the nature of the operation. Okay. And that is what we call slotting combination. So what do I mean by slot? Okay, so a slot is when you want to make a component like this. Okay, so you want to make a channel. Okay, or any milling operation, you usually have to start with a slotting operation. Okay, so if we were to view this from the plan view, so if I were to draw my transformation X, Y, and Z, and if we were to look at the Z an X view. Right. So this is the feature that we want to machine.